What's up, you freaking geniuses? So in this video, I'm going to teach you how to factor a sum of cubes, okay? Now, if you need a quick introduction into that, I'll link a video to that in the card above, because in this video, I'm going to go over some slightly more complicated examples, all right? But this is basically the formula you use when you're trying to factor a sum of cubes, okay? So here, as you can see, we have a cubed plus b cubed, and if you want to factor this, it's simply going to be equal to this formula right here, okay? But the first thing, before plugging it into the formula, the first thing you have to do is first take the cube root of each of these terms, okay? When you take the cube root of a cubed, the cube root and the cubed exponent basically cancel each other out, and you're just left with a, okay? And it's the same thing over here. When you take the cube root of b cubed, those cancel out, and you're just left with b, okay? So that's how you solve for the numbers right there. And then once you have the numbers, then you can plug it into this equation right here, okay? So let's start with this problem right here. 2m to the 6th plus 54m cubed. Okay, so before using this formula, the first thing you want to do is factor out your greatest common factor, okay? And when you factor stuff out, it's the same thing as dividing, okay? So the first thing that we can factor out is a 2, right? Because both of these terms right here are divisible by 2. All right, the other thing we can pull out is an m cubed, right? Because here I have 6 m's, here I have 3 m's, so I can pull out at least 3 m's from each of these, right? Or in other words, both of these terms are divisible by m cubed, okay? So then once we factor that out, what's left in our parentheses right here? Well, we have a 2 here, but we pulled it out, so that goes away, okay? Here I have 6 m's, but we pulled out 3 of them. We factor out 3 of them, right? So we're just left with 3 m's right there, okay? So this would be m cubed, okay? And then here, again, factoring is the same thing as dividing. So 54, we factored out a 2, so we could say 54 divided by 2. And 54 divided by 2 is equal to 27, right? So here we have positive, right, 27. And then here we have an m cubed. We have 3 m's, right? But we pulled 3 of them out, so then we don't have any left right there, right? So we just have a 27 left right there. Okay, cool. Now you might notice inside of these parentheses, we have 2 terms, okay? And they're both perfect cubes, okay? Here we have m cubed, and here we have 27, and 27 is the same thing as 3 cubed, right? So since we have a sum of cubes right here, again, we can factor it using this formula, okay? But again, the first thing you have to do is take the cube root of each of these terms, okay? So if you take the cube root of m cubed, you're just going to be left with m. And if you take the cube root, if you take the cube root of 27, you're just going to be left with 3, right? So this is basically your a, and this is your b, okay? So if you want to factor this thing inside of the parentheses, now that we know what a and b are, now we can use our formula up here, okay? So first of all, we're going to have a plus b in parentheses, right? So we're going to have m plus 3 in parentheses, okay? And then in this set of parentheses, we're going to have a squared minus a times b plus b squared, right? So first of all, a squared is going to be m squared, right? And then it's going to be minus a times b, so m times 3, that's also equal to 3m, right? So we could write it like that, 3m. And then plus b squared, so plus 3 squared, okay? But if you notice something, 3 squared, that's the same thing as 9, right? So instead of leaving it as 3 squared, we can simplify that to just 9. Okay, so we completely factored what was inside of our parentheses right here. The last thing we have to do is take this term that we factored out and just bring it straight down, right? Still out here in front. Okay, so then this would be your factored answer. All right, so hopefully that wasn't too bad. Let's just try a couple more examples. Okay, so here is our next example. So we have 4r to the 6th s cubed plus 4000 r cubed s to the 6th. Okay, so again, the first thing you want to do is factor out your greatest common factor from both of these, right? So both of these terms right here are divisible by 4, so we can pull out a 4, right? Here we have 6 r's, here we have 3 r's, so we can pull out at least 3 r's from each of them, right? So 3 cubed. And then here we have 3 s's, and here we have 6 s's. So again, we can pull out at least 3 s's from each of them, right? So we're going to have s cubed, okay? And then in parentheses, what are we left with? Well, here we have a 4, but we pulled it out, okay? So that goes away. Here we have 6 r's, but we pulled out 3 of them, so we're just going to be left with 3 r's right there, right? So r cubed. And then here we have 3 s's, but we pulled all of them out, so there's nothing left right there, okay? So we're just left with r cubed right there, and then that's going to be plus. Now here 4,000, again, factoring is the same thing as dividing, so 4,000 divided by 4, that's equal to 1,000, right? So plus 1,000. And then here we have 3 r's, but we pulled out 3 r's, so there's none left. And then here we have 6 s's, but we pulled out 3 of them, so we're only left with 3 s's, right? So s cubed, okay? Now, you might notice something. We have some perfect cubes, right? R cubed, that's a perfect cube. S cubed, that's also a perfect cube. But 1,000 right here is also a perfect cube, okay? 1,000 is the same thing as 10 cubed, or 10 to the 3rd power. Okay, so we have a sum of cubes right here. So again, that means we can use our formula up here, all right? So again, the first thing you want to do is take the cube root of each of these, okay? So first of all, the cube root of, let me put the 3 right there to make it clear. The cube root of r cubed, that's just going to be equal to r, okay? And the cube root of 1,000 s cubed, well, the other way you can think about this is take the cube root of 1,000 and take the cube root of s cubed. Okay, so first of all, what's the cube root of 1,000? Well, that's equal to 10, right, as we just saw right here. Okay, so the cube root of 1,000 is equal to 10. And we're adding, right, so we have plus 10. And then here, the cube root of s cubed is just going to be s, right? This 3 and this 3 cancel out, so we're just left with s right there. Okay, so we have 10s right there. Okay, so again, this is my A term and this is my B term, right? So to, again, factor what's inside of these parentheses, now that we figured out what A and B are, now we can plug it into the formula, right? So it's going to be equal to A plus B in parentheses, okay? So R plus 10s, and then our other one is A squared, so R squared, minus A times B, so minus r times 10s, so we can write that as 10rs, okay? And then plus b squared, so plus 10s squared, right? Plus, now this is the tricky part. Don't just write it as 10s squared like that, okay? Because here it looks like you're just squaring the s, but in reality what we're doing is taking this whole thing, right? Because this whole thing is our b term, and we're squaring that, okay? And now we can also simplify this. Okay, so the way you apply the exponent to this term in here is you have to apply it to the 10 and to the s, okay? So let's do that off to the side right here. Okay, so 10s, and we're squaring the whole thing, right? So apply the exponent to everything that's inside of your parentheses right here. So you have to apply it to the 10 and to the s. Okay, so first of all, 10 squared, that's equal to 100, right? And then s squared, that's just s squared. Okay, so then here we're going to have 100s squared. So I'm going to take this out, and I'm going to replace it with the answer, or the simplified answer that we just found right here. So 100s squared, right? So 100s squared. Okay, now I can also close my parentheses, right? Okay, cool. So we just finished factoring what was inside of our parentheses, right? We just plugged it into our formula right there, okay? Now the last thing we have to do is take this term that we factored out at the very beginning, right? Very important, don't forget that, and bring that straight down. So 4r cubed s cubed. Okay, so then that right there would be your final factored answer. All right, let's just try one more example. All right, so here is our last example. So we have x cubed plus y cubed plus x squared y plus xy squared. All right, so again, the first thing you want to do is factor out your greatest common factor, right? But the issue here is that there is no greatest common factor, right? There's no factors that all these 4 terms have in common, right? So there's nothing I can pull out. Now, the other thing going on here is we have 4 different terms, right? And when you have 4 different terms, one of the best ways you can factor this is by grouping, okay? And the way that you factor by grouping is simply taking your first 2 terms, so x cubed and y cubed in this case, take those 2 terms, put those in a set of parentheses, and then take your last 2 terms and put those in a set of parentheses, okay? And then you just factor each of these parentheses individually, separately, okay? So first of all, let's factor this one right here, x cubed plus y cubed. Well, if you notice right off the bat, we have 2 perfect cubes, right? And we're adding them. So this is a sum of cubes. So guess what? We get to use our formula up here, all right? Now, again, the first thing you want to do is take the cube root of each of your terms right here, okay? So the cube root of x cubed, that's just x, right? And then the cube root of y cubed is just y, right? So this is our a and this is our b, okay? So now that we know what those are, now we can plug it into our formula right here. Okay, so first of all, we're going to have a plus b in parentheses. Okay, so x plus y in parentheses. And then in our other set of parentheses, we're going to have a squared minus ab plus b squared, right? So a squared is going to be x squared, and then minus ab is going to be minus xy, and then plus b squared is going to be plus y squared, right? And then we close our parentheses right there. Okay, cool. So I just finished factoring these set of parentheses right here, right? Now let's factor these 2. Okay, so here we have x squared times y plus xy squared. So do both of these terms right here have a greatest common factor that I can factor out? Well, they do, right? Because here I have 2 x's, right? And here I have 1 x, so I can pull out at least 1 x from both of those. So here we're going to put plus x, okay? Remember, we're still factoring this gigantic thing by grouping. So whenever you do that, make sure you, for this second term right here, always put your plus sign right there, okay? And I can pull out an x, right? And the other thing I can do is pull out a y, right? Because here we have 1 y, here we have 2 y's, so I can pull out at least 1 y from both of these. So we'll also pull out a y right there. And then what's left in our parentheses right here? Well, here we have 2 x's, but we pulled out 1, so we're only left with 1x right there, so 1x. Here we have a single y, but we pulled it out, so there's nothing left right there. Then here we're going to have plus, right? Here there's 1x, but again we pulled out 1x, so there's nothing there. And here there's 2 y's, we pulled out one of the y's, so we're only left with a single y, so just y. Okay, now that we factored each of our parentheses up here individually, you'll always notice something whenever you're factoring by grouping, and that is you're going to have the exact same thing in 2 of your parentheses. Okay, so for example, here we have x plus y, and here we also have x plus y. Okay, so to finish factoring this gigantic thing by grouping, all you have to do is take your similar parentheses right here and just write it once. So we're going to write, let's move it over a little bit. We're going to write it once, x plus y. I know there's 2 of them, but you only write it once. So that goes away and that goes away, right? And then we're going to multiply that by another set of parentheses. And what do you put here? Well, whatever's left, which would be this set of parentheses and this out here, right? Plus xy. Okay, so that's what goes here. So we're going to have x squared minus xy plus y squared, and then this plus xy at the end. Okay, now we're almost done, but there's something we can simplify right here, and that is we have a minus xy and a positive xy, right? So those are just going to cancel each other out, right? So then lastly, we're going to be left with x plus y, these parentheses right there, and then in these parentheses, we're going to be left with x squared plus y squared, right? X squared plus y squared, right? So then that right there would be your final answer. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below. Also, there's a couple playlists attached that I think you'll find helpful, so definitely check those out, and I'll see you there.